remember if anybody was absent. If you are missing this, sorry, I missed the first 5 minutes. Copy that down. Okay, now go. This is where we're at now. Sorry. Okay. 1/2 plus 1/2 cosine 2x dx. Okay, you have 1/2 x plus 1/4 sine of 2x, or if you like, just like before, a half times a half. Whichever one's fine. Are we cool? Okay. Big idea, that's the idea. You reduce the power by an identity, and you need to study those identities. Just little wrinkles here and there, and we'll be good to go. When you reduce, it's really doubled the previous angle, so that if the angle was 4x to begin with, then you will get double the previous angle on the identity. So when I replace this, it'll become a half minus a half of cosine double the previous angle. So cosine of 8x. It's double the previous angle when you use this identity. All right. After that, the first integration is easy. 1/2 x minus 1/2. And then again, it's that be careful with the undoing the cosine of 8x. What's the antiderivative of cosine of 8x? 1/8 sine of 8x. Right? Let's see, or you can see it could be a 1/16. And I don't care if you leave a factor or you distribute, whatever you want. You with me? Okay. Cosine of the fourth. This is where it starts to get a little up. What do you reckon we should do to start with? Does it do any good to split now? If I split off a single cosine, would that get me anywhere? Not really, because that cosine cubed, I don't have anything for that. It doesn't go anywhere. So it is still this identity. The only difference is it'll be squared. And so I'll have to multiply cosine squared's identity times cosine squared's identity. And so now I'll get a bunch of foiling mess, and it's all good. So cosine squared is 1/2 plus 1/2 cosine 2x. Some students like to take out the half, some don't. It's up to you. But I need to FOIL. I get 1/4 plus a fourth cosine 2x plus another fourth cosine 2x is a half cosine 2x. And then the dreadful term is the 1/4 cosine squared of 2x. And that, you might see, will mean I'll reduce it again. All right? Yeah, terrible. Okay? Now, I'm going to integrate a few of these guys, the easy ones. A fourth's antiderivative is 1/4 x. A half cosine 2x is antiderivative. 1/4 sine of 2x. Then maybe pull out the fourth out front, but when I sub for cosine squared, what's the identity that will reduce cosine squared of 2x? 1/2 plus 1/2 cosine of 4x. Follow? So I'll get a 4th x plus a 4th of sine of 2x plus an 8th of an x plus an 8th times the antiderivative of cosine 4x. What's the antiderivative of cosine of 4x? Sine of 4x divided by 4. And so altogether you'd have a 32nd for that last term, right? You see? That's pretty much as ugly as you'll see. Okay, try one application on your own, and we'll call it good. Combining the few ideas. Okay, let me, is this a disc or a washer? You haven't done shells yet. Disc or washer? Disc. First quadrant, when would the first region in the first quadrant end? Pi over 2 or pi? Pi over 2. The period would be pi for a full wave. So a half wave would end at pi over 2, and you said it was a disk. I agree, because there is no gap between the axis of symmetry. And so it's straight up just pi r squared. There's no big R squared, no little r squared kind of thing. It's just it's x because we're around the x-axis, and it is sine squared from 0 to pi over 2. The antiderivative. Oh. Did I make a mistake? Oh, 2x. Thank you. Yes. Oh, shucks. What a mess. Sorry. Sine of 2x quantity squared. How's that? Sorry about that. Okay, 1/2 minus 1/2 cosine of 4x. Sweet. Dx from 0 to pi over 2. Pi 1/2 x minus 1/8 sine 4x from 0 to pi over 2. I believe, if I recall, I got pi squared over 4. Yes? Is that what you got? No? Yes? Am I making that up? Okay. All right. So, shall we talk about page 1 of the test? I haven't decided on a curve yet, so that's why it's not